If you have not seen our previous video explaining the concept of DAG, task instances and operators, please go and watch that video first. If you are already aware about these concepts, you can continue with this video. Let's assume a scenario where we need to fetch sales data from diverse sources, transform and load data into the data warehouse, automate daily reporting and analytics tasks. While doing it, we also need to ensure task dependencies, scheduling and monitoring for efficient workflow management. Following components are helpful to understand how Airflow can make this job possible. The very first component of Airflow is the scheduler. Imagine you have a daily data processing pipeline where task B depends on task A's completion. Task A retrieves raw data from external API and task B performs data transformation. The scheduler ensures that task A runs first and then triggers task B only if task A successfully completes. This ensures the pipeline's tasks are executed in correct order, maintaining data integrity and workflow logic. The scheduler is responsible for scheduling and executing tasks defined in Airflow DAGs. It continuously monitors DAGs and triggers task instances based on their dependencies and scheduling settings. The scheduler uses configured executor. Example, sequential executor, local executor, celery executor to execute tasks on worker nodes. Which brings us to our next component, that is executor. The executor is responsible for executing task instance on worker nodes or on computing resource. Airflow supports different types of executors such as sequential executor for single node execution, local executor for parallel execution on same machine, celery executor for distributed execution using celery, and Kubernetes executor for containerized execution on Kubernetes cluster. Consider a scenario where you have a large-scale data ingestion pipeline. You are receiving massive amounts of data that need to be processed and stored in your data warehouse. Using Airflow Celery Executor, you can deploy multiple worker nodes, which we call celery workers, that distribute the data processing task across the clusters. The parallel execution capability of Celery Executor significantly reduces processing time and scales seamlessly as your data workload increases. However, for big data applications, we can go for a framework like Apache Spark, as we can also schedule Spark applications using Airflow. Executors can handle task execution, monitor task statuses, communicate task result back to Airflow Metadata Database. Which brings us to the third component, which is Metadata Database. Airflow uses a metadata database to store and manage metadata related to DAGs, tasks, task instances, execution logs, and historical run information. In production environment, handling sensitive customer data, data reliability and consistency are paramount. By configuring Airflow to use a robust database like PostgreSQL as the metadata store, you ensure that metadata related to DAGs, task statuses, and execution logs are securely stored and managed. Commonly used databases for metadata store include PostgreSQL, MySQL, SQLite, and other databases supported by SQL Alchemy. The fourth component is web interface. Airflow provides a web-based user interface that allows user to interact with and manage Airflow components, DAGs, and task instances. The web UI provides features such as DAG visualization, task monitoring, task logs, scheduling controls, and administrative capabilities as well. Suppose you are overseeing a team of data engineers managing multiple data pipelines using Airflow web UI. You can visually monitor the progress of various DAG runs, check task statuses, and view task logs in real time. This visibility allows you to identify bottlenecks, troubleshoot issues efficiently, and make informed decisions to optimize workflow performance, all through a user-friendly interface accessible via a web browser. The fifth component of Airflow is a scheduler process. The scheduler process runs continuously as a daemon or service to orchestrate task scheduling and execution. It periodically checks scheduling interval for each DAG and triggers task instances based on dependencies, time schedules, or external triggers. In dynamic data environment, where external events trigger workflow execution, such as receiving new data files at specific intervals, the scheduler process plays a crucial role. For instance, you can configure Airflow to monitor a specific directory for new file arrivals. Upon detecting a new file, the scheduler triggers a DAG run automatically, initiating further data processing tasks to ingest and process the newly arrived data without manual intervention. The scheduler communicates with Metadata Database to retrieve DAG definition, task dependencies, and execution statuses to make scheduling decisions. It's very easy to get confused between the scheduler and the scheduler process. Scheduler process is like scheduler's assistant who actually makes sure task gets done on time. Here is how it helps. The scheduler process works non-stop, checking the schedule regularly to see if any tasks need to be started or completed. When a task is due, the scheduler process talks to right team member called an executor and asks them to do the task. It also keeps everyone in loop by updating the task list and making sure everyone knows what tasks are done and what's next. So in simple terms, scheduler is the brain that plans project's task, while scheduler process is the helper that makes sure those tasks actually happen on time by talking to right team members and keeping everyone organized. The sixth component of Airflow is worker process. Worker processes are responsible for executing task instances on worker nodes or on computing resources. In distributed execution setups, worker processes receive tasks from scheduler or broker and execute them in parallel across multiple worker nodes. For more about distributed setups, we will cover these topics in upcoming videos. Workers communicate task execution details, logs, and results back to the metadata database for monitoring and tracking purpose. These components work together to enable workflow orchestration, task execution, monitoring, and management within Apache Airflow. Understanding how these components interact helps in deploying and operating Airflow effectively for data pipeline automation and management. Thanks for watching. Don't forget to like, share, and subscribe. By the way, this monkey-like looking creature in the pic, it's me.